Chapter 3, Lesson 6, Proportional and Non-Proportional Relationships. So when we talk about proportional relationships are going to be in the form of the equation y equals kx. So we remember that that's the same thing as a direct variation. So a proportional relationship, every single time that k value or the slope is going to equal the y over the x. So when we put y over x, that should be a constant number, the same number every single time when we have a proportional relationship. The only time that's not going to be true is if x equals 0. So x can equal 0, but in order to be a constant, the x isn't going to be 0. So as we know in a direct variation, this equation, this line does go through the origin, so x will be 0 and y is 0. But if we do 0 divided by 0, we're not going to get that constant number there. A non-proportional relationship, there is a pattern between x and y, all right? And there is a relationship, but it's not proportional. So y over x is not going to equal a constant, all right? There's going to be a different type of constant. As our x increases, our y is going to either increase or decrease, and it's going to increase or decrease by a pattern, but it's not going to be a proportional pattern. We also know that this graph is not going to pass through the origin because it has a y-intercept that's not 0. So this is when we think about an equation that's more in slope-intercept form, which we'll talk more about later, y equals mx plus b. And so this number right here is going to be some number not equal to 0. It's going to actually be something. And then this m is going to be our slope of the line, or kind of like that k value, even though that k isn't, it's still a constant, even though it's not proportionate between x and y. Talk about some similarities and differences between proportional and non-proportional equations and functions and lines. Proportional, we know, passes through the origin, and non-proportional, we know, does not. It can't. It does not pass through the origin. Both of these equations are linear. So a proportional relationship and a non-proportional, both are linear. Proportional, y over x, is a constant. It's the same number every time. And in non-proportional, y over x is different every time. All right, so we can do y over x, but in proportional, every time we do it, it gives us a constant value, and non-proportional will give us a different value. Now, this is different than saying the change in y's. We're just putting a y value over an x value and seeing what happens. Our proportional relationship is in that form of y equals kx. K is the slope, it's a constant number. And over here, it's y equals mx plus b. So the big difference is that it has this number here, which is actually our y-intercept. In both of these types of equations, the x and y's create a pattern. So in proportional and non-proportional, our x and y's create a pattern. So let's look at an example and see if we can decide, is it proportional or non-proportional? So all I'm going to do is I'm going to put y over x, and I'm going to see what happens. So let's look at my first pair here. Y over x, 9 over 1, so it's 9. In the next one, 12 over 2 is 6. Well, those two are not equal to each other, so it is non-proportional. Okay, and then I'm going to say, well then, if it's non-proportional, let me see if I can write an equation in that form. Y equals mx plus b. So what I'm going to do is I'm going to see if I can find what's the pattern of my y's. All right, so my pattern of my y's is plus 3, plus 3, plus 3, because there's a constant pattern there. But that pattern isn't proportional, so it's not like every time I have an x value I do times 3. But let's see what happens. If I had y equals 3x, because that's my pattern in my y's. Add 3, add 3, add 3, add 3. So it's something with multiples of 3. So if I had y equals 3x, well, if x is 1, and I put in a 1 here, 3 times 1 doesn't give me 9. Let's say I have a 2. 3 times 2, well, that doesn't give me 12. It gives me 6. If x is 3, 3 times 3 is 9. But it needs to be 15. Well, what's happening every time? Every time I get a number that is 6 below what I need it to be. So what I need to do is I need to add 6 to that 3 times x. And now if I plug in a 1, let's say plus 6, 3 times 1 is 3, plus 6, oh, that's 9. 3 times 2 is 6, plus 6 is 12. 3 times 3 is 9, plus 6 is 15, and 3 times 4 is 12, plus 6 is 18. And now I have my equation that goes with my non-proportional relationship.